Video 12. Airplane cabins are specially engineered spaces designed to keep passengers safe, comfortable, and healthy while flying at extremely high altitudes. When an aircraft cruises at 35,000 feet, the outside air pressure is too low for humans to breathe normally. To counter this, cabins are pressurized to maintain a pressure level similar to living at 6,000 to 8,000 feet above sea level. This prevents hypoxia, headaches, dizziness, and other altitude-related issues. Cabin pressurization is controlled by the aircraft's environmental control system, which constantly adjusts the air pressure to match safe levels throughout the flight. Modern cabins also feature advanced climate control. The temperature outside the aircraft can drop to -50 degrees Celsius at altitude, but inside the cabin, passengers experience comfortable and stable temperatures. The system maintains airflow, humidity, and ventilation, ensuring a steady supply of fresh, filtered air. About 50% of the cabin air is recirculated, passing through HEPA filters to remove dust, bacteria, and pathogens. The remaining 50% comes from compressed fresh air taken directly from the engine's compressors, or dedicated air systems. Oxygen safety is another essential part of cabin design. In the event of a sudden drop in cabin pressure, oxygen masks automatically deploy from overhead compartments within seconds. These masks supply a mixture of oxygen that allows passengers to breathe safely until the aircraft descends to a breathable altitude. Pilots have their own dedicated oxygen system to maintain control of the aircraft during emergencies. Cabins are also designed with comfort in mind. Seating arrangements vary from economy to first class, each offering different levels of legroom, cushioning, and adjustability. Lighting plays an important role, as modern aircraft use LED mood lighting to reduce jet lag. Passengers and create a pleasant atmosphere. During takeoff and landing, cabin lights are dimmed to help passengers adjust their eyes in case of an emergency evacuation. In-flight entertainment systems, touch screens, Wi-Fi, and charging ports further enhance the passenger experience, making long flights more enjoyable. Safety features are integrated everywhere. Multiple emergency exits are positioned across the cabin, each clearly marked and equipped with lighting paths on the floor that guide passengers in low visibility. Slides attached to the doors allow for rapid evacuation during emergencies. Fire suppression systems are built into galleys, lavatories, and cargo compartments. Smoke detectors alert crew instantly if any smoke is detected, especially in bathrooms where hidden fires could be dangerous. The fuselage itself plays a major role in cabin safety. The aircraft's body is built using strong, flexible materials like aluminum alloys and carbon fiber composites. These materials allow the cabin to withstand high-speed flight, pressure changes, and turbulence. The fuselage is shaped to distribute pressure evenly, reducing stress on the structure and ensuring that the cabin remains airtight. Windows are carefully designed with multiple layers to prevent cracking under pressure differences. Cabin altitude is controlled during ascent and descent to avoid discomfort. The pressure changes slowly and smoothly to prevent ear pain and discomfort. Quiet cabin technology, engine placement, and sound-absorbing materials reduce noise levels, creating a more peaceful environment for passengers. Crew members use intercom systems, emergency equipment, and communication panels to ensure safety and provide assistance. Flight attendants are trained to handle medical emergencies, evacuations, and passenger issues. The cabin is equipped with first aid kits, defibrillators, and medical supplies for in-flight health situations. Cabin design also includes storage systems, such as overhead bins, that can securely hold carry-on bags during turbulence. Lavatories are compact but designed for hygiene, accessibility, and safety. Galleys contain ovens, storage units, beverage carts, and safety latches to keep all equipment secure during turbulence or sudden movements. Pressurization systems rely on valves that control how much air is released from the cabin. Outflow valves at the rear of the aircraft continuously adjust to maintain the correct cabin pressure. If the pressurization system fails, backup systems automatically activate. Pilots can also manually control cabin pressure if needed. Passengers may not realize how much engineering goes into creating a comfortable cabin environment. Everything from seat design to air circulation has been tested to meet strict aviation standards. The cabin must remain intact during high-impact situations, rapid decompression, or extreme turbulence. Materials used in the cabin must be fire-resistant, lightweight, and durable. Even the overhead panels and walls are made to withstand sudden pressure changes. Emergency lights activate automatically when power is lost. Floors are reinforced to support heavy items like service carts and passengers moving around the cabin. Cabin windows are small for safety reasons. The rounded shape prevents cracks and structural stress. Each window has an inner pane with a small hole called a breather hole that regulates pressure between the window layers. Seat belts secure passengers during turbulence, and tray tables are designed to lock firmly to prevent injuries. Airplane cabins are constantly evolving. Newer aircraft like the Boeing 787 and Airbus A350 use advanced materials, larger windows, higher humidity levels, and better oxygenation. These improvements help reduce fatigue, dehydration, and jet lag. In short, the cabin is not just a place to sit. It is a highly controlled, carefully engineered environment that ensures safety, comfort, and health. From pressurization to lighting, from structural strength to emergency equipment, every aspect is designed with precision. In the next video, we will explore avionics, the complex electronic systems that act as the brain of modern aircraft, helping pilots monitor everything from navigation to communication.